Okay, so I'm actually recording this from my house. So if anything is any different on this, I do apologize. Hopefully, you guys can bear with me get this done. You will have a sub. You should be with a sub today. If you're in my homeroom, probably today and tomorrow. But we're going to continue things like they are normally. So instead of doing math in class, you're going to be doing it with me on here. So I'm really not going to go over chapter 3 review test with you. I'm not going to do it all for you. I am going to go over some of it because I want you guys to try to see what you guys would be able to do by yourself. But what I'm going to do the first probably 2 pages with you, and I'm gonna turn you loose on the rest of it because this is kind of what the test looks like. We're not going to give you a test because you weren't at school every day for the entire chapter. So we're just going to review some of this, and I'm going to turn you loose and do the rest on your own. If you do have questions, the sub there definitely can answer that. And also, if you have questions, if you're in my home room, let's say you don't know, you're really lost on number 10. Well, I want you to give it a try, but I want you to circle it, okay? Circle it, and when I come back, we'll definitely go through that and see which ones you're having trouble with and why. But we are going to do probably the first 2 to 3 pages. So follow along. So number 1 says there are 3 boats on the lake. 6 people ride in each boat. How many people ride in the boats? Draw circles to help you model the problem. So we know we have 3 boats, 1 boat, 2 boats, and 3 boats. And each boat is going to have 6 people in it. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Let me see if I can. The sensitivity on this is pretty high. It moves around real fast. So each boat has 6 people in it. There's 3 boats, which gives us the problem of 3 times 6. And if you look on your multiplication chart, or if you skip count 3 6 times, you're going to get 18. And if you count all those, you will have 18. And that's number 1. Number 2, Nadia has 4 sheets of stickers. There are 8 stickers on each sheet. She wrote this number sentence down to represent the total number of stickers. So she has 4 sheets, like 4 sheets of paper with 8 on each sheet. 8. So 4 times 8 equals 32. That is the correct multiplication sentence. But let's see. Which of these related sentences also represents the total? Well, if it represents the total, it has to equal 32. So 8 plus 4 we know equals 12. So that cannot be a problem. That's not an answer. 4 plus 4 makes 8. 8 plus 4 makes 12. 12 plus 4 makes 16. Guess what? That is not equal to 32. That is not an answer. 8 times 8. If you skip count 8 times or look on your multiplication chart before you know your 8s, we know that 8 times 8 is equal to 64. Okay, so that can't be a problem. But 4 times 8 and 8 times 4, commutative property of addition tells me 8 times 4 will equal 32 because 4 times 8 equals 32. So the answer right here is D, number 4. Let's go to number 3. Lindsay went hiking for 2 days in Yellowstone National Park. The first jump on the number line shows how many birds she saw the first day. She saw the same amount of birds the next day. So she has 2 days and she saw the same amount each day. So we have 2 days or 2 jumps. We know that's going to be the first number. And 0 to 8 and 8 to 16. We know they jumped each time equally, which is 8. And 2 times 8, it ended on 16. Simple as that. 2 jumps is 2 is the first number, which is 2 days. and they saw 8 birds each day because 0 to 8 and 8 to 16 is 8, and they are equal. So 2 times 8 is 16. Paco drew an array to show the number of desks in his classroom. We know we have 3 down and 7 across. So that gives us a multiplication. 3 times 7 equals. We can go through and count them all. We can do 3 times 7, or we can do 7 times 3, the commutative property of it. If you go through and count these all, like 3, 6, 9, 12, 15, 18, 21, we know that 3 times 7 will be 21. 21 what? Desk. My handwriting is going to be a little bit sloppier because the tablet I'm using at home to write this on is a little bit quicker than the one I use at school. So if it's a little bit sloppy, guys, just give me a little, bear with me. The next one. It says, Alondra makes 4 necklaces. She uses 5 beads on each necklace. For 5A through D, we're going to say yes or no to tell if it is true. Well, first off, before we do anything, I want to solve 4 times 5. Because if none of these equal what 4 times 5 equals, then we know it's a no. And 4 times 5 equals 20. So 4 times 5, does that equal 20? Yes. 4 plus 4 makes 8. 8 plus 4 makes 12. 12 plus 4 makes 16. Does that equal 20? No. 5 plus 5 is 10. 10 plus 5 is 15. 15 plus 5 is 20. So guess what? That could be a yes. 5 plus 4 equals 9. We know automatically that is a no. That's a quick one. The next one. John sold 3 baskets of apples at the market. Each basket contained 9 apples. How many apples did John sell? Make a bar model to show. So we know that he has 3 baskets. So I'm going to take this bar model and I'm going to divide it into 3s. I know that's not equal, but we'll make them as close. So we have 3 baskets. And there's 9 in basket 1, 9 in basket 2, 9 in basket 3. So I have 3 baskets with 9 in each. If I take 9 plus 9 plus 9, or 3 times 9, which is the same thing, you're going to get 27 apples. 27. And I'm going to do this page with you, and I'll let you do the last. I'm going to do the next 2 pages with you, and I'll let you do the last 2 pages by yourself, okay? Okay, sounds like a plan. Select the number of sentences that show the commutative property. We know commutative property is the same as 1 times 2 equals 2 times 1. They just switch places. Mark all that apply, which means they're going to be more than 1. So 3 times 2 is the same as 2 times 3. Definitely, we know that is true. 4 times 9 is the same as 4 times 9. That is true, but did they switch places? No. 5 times 0 equals 0. They didn't switch places. They didn't do anything, so no. That's called the 0 property of multiplication. 6 times 1 is the same as 1 times 6. Yes. Lastly, 7 times 2 is the same as 14 times 1. While they both equal 14, that is no. Those are 2 separate problems. So it's A and D. A and D. The next one. A waiter carried 6 baskets containing 5 dinner rolls. How many dinner rolls did she carry? Show your work. So we have 6 baskets. I'm going to draw 6 circles. Let's do our drawing here. 1, 2, 3, 4, 5, 6. So I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And you could even put the number 5 in any of them. So we have 5 in each. We have 6 baskets. So I'm gonna go 5, 10, 15, 20, 25, 30. That's simple. We skip count 5, 6 times. You have 30 dinner rolls. Or you could skip count 6, 5 times. It'd be a little bit tougher. Sonia needs 3 equal lengths of wire to make 3 bracelets. The jump on the number line shows the length of one wire in inches. How many inches will Sonia need to make 3 bracelets? So she has 1 jump. She needs 3 jumps, and they all have to be 0 to 6. So they all have to be 6. They have to be equal. So if we skip count 0 to 6, we get 1 jump of 6. 6 plus 6 is 12. That's 2 jumps. We need 1 more jump. 12 plus 6 is 18. So we have 3 jumps, all of 6, which is 3 times 6, which equals, she needs a total of 18 inches. Okay? This 3 kind of really didn't matter. This length did. Okay? Or those are each bracelets. So 3 and 3. Bam, bam. Number 10. Joss has 4 dogs. Each dog gets 2 biscuits every day. How many biscuits will Joss need for all of his dogs for Saturday and Sunday? Well, I know that he has 4 dogs, right? And they each get 2 biscuits every day. So 4 times 2. So every day, Joss gives out 8 biscuits. Okay? 1 day is 8 biscuits. But now he has 2 days, Saturday and Sunday. Saturday and Sunday, he's giving out 8 on Saturday and 8 on Sunday. What's 8 plus 8 is 16. You've also done 2 days times 8, which also is the same as 16. So he will need 16 biscuits. 16. Number 11. George displayed 28 cans of paint on his shelf in his store. Select other ways that George could arrange the same number of cans. So first off, let's find our total. He has 4 across and 7, 4 down and 7 across, which equals 28 total cans. So every one of these has to equal 28. 2 rows of 14, 2 times 14, that does equal 28. So he could do it. 1 row of 28, which is 1 times 28, which does equal 28. So he could do it. 6 rows of 5, which is 6 times 5 or 5 times 6, which equals 30. He could not do it. 8 rows of 3, which is 8 times 3 or 3 times 8, which equals 24, which means he could not do it. Lastly, 7 rows of 4, which is 7 times 4 or 4 times 7, which equals 28, which means he could do it. So he could have done it any of those three ways. All right. It says choose the number that makes this statement true. The product of any number, which is the answer, guys. This is the answer to a multiplication sentence. So the answer of any multiplication sentence, the product of any number and what is 0. So you times any number in the world, any number, and it equals 0. What's the other factor going to be? 0. Okay? Anything times 0 is 0. Anything. The biggest number in the world you can think of times 0 will be 0. Number 13. I'm going to do 13A and B, and I'll let you do the last 2 pages by yourself. And when you're finished with this, guys, you guys know to do ST and ST only. James made 3 times 5. So he has 3 down the side and 5 across the top. And that does equal 15. James says that 5 times 3 is correct. Draw an array to show your answer. So now instead of 3 down, we have 5 down. 1, 2, 3, 4, 5. We're going to have 3 across. 1. If we fill this in just like this, it will still equal 15. So explain your answer. 5 times 3 or 3 times 5 equals the same as 5 times 3. That is commutative property of multiplication. But let's just put commutative property. Okay, what's property supports your answer? Put commutative property right here. And that's the answer. Commutative property of multiplication. I should have read that one prior to doing this. So commutative property of multiplication goes on this line. Do the next 2 pages by yourself. Remember, if you are struggling with some, circle it. Myself and or Miss Campbell will go over it. Other than that, you guys should be good to go, okay? Make sure you're good. My class for the substitute, please.